Okay, in this video, we're going to go into the inverse cosine function. So back in Maths 1, so we did the graph on the cosine function. And these are going to be the one period of a cosine function. So I think if you watch your sine inverse function, so you should know that this one will be fail a one-to-one function. To have an inverse, it fails a one-to-one function. So you need to restrict some certain domain on your graph. So over this side, okay, for the cosine function, the domain that we restricted is going to be between 0 to pi. Okay, where your horizontal line test intercept at only 1 point. So it pass. Okay, by the way, for certain book, it might be a different domain that they restricted. So for our book, for our textbook, we use it between 0 to pi. So I already cut and paste for the smaller scale. Now this is going to be the blue color graph. Okay, the blue color graph would be your cosine function. So this is a function of y equivalent to cosine x. Right. Now again, your graph would be, your domain would be from 0. This is going to be 0 until pi. Alright. And your range would be between 1 until negative 1. And if you want to have your inverse function graph, so what you do is that you reflect about the graph or the line of y equivalent to x. So you're going to have this red color graph. Okay, so I'm not going to show you the detail how to draw the graph, but just you have to know. So this is the function of y equivalent to cosine inverse x. Okay. For y equivalent to cosine x, okay, now you can see that just now we restrict the domain is between 0 to pi. And you're going to have the range of negative 1 until 1. Thus, your y equivalent to cosine inverse x, because we have the properties of when your domain of f equivalent to range of f inverse, and your range of f equivalent to domain of f inverse, so it flips over lah. Domain of cosine inverse would be between negative 1 until 1 and your range between 0 to pi. Now, let's look at the example. This is from the example 27 in a page of 76 if I'm not mistaken. Okay, so they ask you to find the exact value on the inverse cosine function, where find the exact value of the following A, B, C and D. Now, let's go through one by one. So, part A. So, if you have cosine inverse 1, so first thing first, what you can do is you let y equivalent to cosine inverse 1. And then, you change it into in term of a cosine y function. So, we have cosine y equivalent to 1. So, you can say this is cosine y equivalent to 1. Alright? Because you cannot straight away get the answer from cosine inverse. So, you have to know your special angle value. Right? Now, where does it fall for the y? The domain for y will be belong between 0 to pi. Now, if you look at over here, 0 to pi will be fall whether at quadrant 1 or quadrant 2. Okay, this is 0 degrees, this is pi degrees. Okay, now, when is it that it happens that you have 1 over here? Is it positive or a negative cosine? So, since it is a positive cosine, will be fall on quadrant 1. So, you should know that, this one fall at quadrant 1 because it's positive. Cosine positive, so it is at quadrant 1. Now, when is it that cosine y will give you 1 over here? So, it happens that the angle of y for cosine will be only y equivalent to 0 degrees. So, the 0 degrees. But if you want to find in terms of exact value, just put 0 radian. So that will be your answer. Okay, as simple as that. You just have to determine what is your quadrant and what is your special angle for that certain exact value. Now let's look at part B. So we have a cosine inverse half. So first thing first is that you let your y equivalent to cosine inverse half. And then because you cannot solve straight away from cosine inverse, you make it cosine y equivalent to half so that we can know the special angle. Now, y falls whether at quadrant Okay, quadrant 1 or quadrant 2 because 0 to pi. Since your y is positive, so over here you have a positive y, so you can say that cosine positive will be fall at quadrant 1 only. So your answer y, now if you draw your graph a bit, okay, so this would be at quadrant 1. So what is the angle of y that will give you half over here? So the angle of 60 degrees. So you have a 60 degrees angle, you should say that cosine 60 degrees will give you half. But we want the answer in terms of exact value, so your 60 degrees, you change it into a radian form. A radian form will tell you this is going to be y equivalent to pi over by 3. Okay, so that's your final answer. Are you okay? Now let's look at something when you have a negative value. So you have cosine inverse negative sec 2 over by 2. Now first thing first, let y equivalent to cosine inverse negative sec 2 over by 2. And then you make it in term of cosine y equivalent to negative sec 2 over by 2. Where y falls in between 0 to pi, you can know whether at quadrant 1 or quadrant 2. Okay, now since your cosine y will be having a negative value, so you have to determine whether at quadrant 1 or quadrant 2. So you have to know from your add sugar to coffee. So what does it tells? Your add sugar to coffee, and we want to look at only these two quadrant 1 or 2. The one that will be having a negative value for cosine will be at quadrant 2. So this quadrant 2. Because first and quadrant will be all is positive, so cosine positive. Second, only sine that is positive, so cosine should be negative value. So over here you can draw that your cosine having a negative value with the angle y over here. Okay, now to get the angle, you cannot get it straight away, so you have to know your reference angle over here that give you the special value or the exact value over here. What is a special angle that give you sec 2 over by 2? So you should know that it will actually give you the theta of 45 degrees, or if it in terms of radian, it will be pi over by 4. Okay, now you want your answer in terms of y. So the angle y or your exact value of y equivalent to, how to get, because it falls on quadrant 2, you have to minus out from the pi. So pi minus by pi over by 4, which you calculate, you will get 3 pi over by 4 will be your final answer. Alright.